Hi, I'm Matt Woodruff, founder of Open Education AI and EdEquity AI, and for the past 8 years, a part-time computer science PhD student at the University of Surrey. A few years ago, into this PhD process, I made a discovery. The AI system I built to identify at-risk students in secondary schools was working, really working, 80% accuracy. The machine learning model could predict which students needed safeguarding interventions before the crisis hit. I should have been celebrating. Instead, I was staring at a number that made me feel sick. 47.4, 47%. That's the gap between how well my model identified disadvantaged students versus their more affluent peers. Students on free school meals, already vulnerable, potentially already struggling, faced 5.2 times higher false positive rates. When the model flagged them as at risk, it was wrong more than half the time. But when it looked at their wealthier classmates, suddenly it became cautious, conservative, accurate. I hadn't built a safeguarding system. I'd built a poverty detector. But here was what was keeping me up at night. I'd followed all the rules. I'd used best practices. I'd done everything the AI ethics guidance told me to do. I'd even removed socioeconomic status from the training data, thinking I was being responsible. That made it worse. The bias didn't disappear. It just became invisible, hiding in proxy variables I couldn't remove because they were actually predictive. Postcode, attendance patterns, a dozen variables I hadn't even considered were carrying the signal of disadvantage. So here's my question for every edtech or AI vendor and education platforms utilising this type of technology. When did you last look at your fairness gaps? Not your accuracy, not your engagement metrics, not your customer testimonials, your fairness gaps. Because I'm willing to bet that most of you have them, but you may not have yet looked. Today, I want to tell you 3 stories. The story of how I fixed the model, not with better algorithms, but with better architecture. The story of how the sector has been solving the wrong problem for 20 years. And the story of what happens when we finally start to ask the right question. When you discover your AI is biased, the guidance offers you 3 standard solutions. First, adjust the decision threshold. Second, reweight your training samples. Third, remove protected characteristics. I tried all 3 of these. The first 2 just move the problem around, making one group better at the expense of another. It's like a fairness seesaw that you can never quite balance. The third was actually worse than doing nothing. When I removed socioeconomic status from the training data, the fairness gap actually increased. The model just learnt to use postcode, attendance history and behavioural patterns as proxies. I'd made the bias invisible without making it disappear. This is what researchers call the impossibility theorem of fairness. You mathematically cannot optimise for all types of fairness simultaneously, unless you stop trying to solve it with maths alone. The breakthrough wasn't a better algorithm. It was understanding that I was trying to make one model do 2 fundamentally different jobs. Some decisions are straightforward. The student is clearly fine or clearly needs help. Other decisions are uncertain, ambiguous, sitting right on the edge of that boundary. And it was in these uncertain cases where my bias was hiding. So I stopped trying to build one perfect model and started building a confidence-based routing system. Here's how it works. Model 1 is conservative and accurate, an explainable boosting machine that's right 93.9% of the time when it says the student is safe. It handles the clear-cut cases, which is about 70% of all decisions. Model 2 is vigilant and sensitive, a rule-based system called Pygol that catches 74.7% of at-risk students, even if it means more false alarms. It's built using inductive logic programming, a technique that learns explicit, human-readable rules. The router asks one question: how confident are we? High confidence? Use the efficient model. Low confidence or disadvantaged student? Use the cautious model. And critically, humans review everything that gets flagged. The hybrid system doubled the detection rate for disadvantaged students from 21 to 42%. Not perfect, nowhere near perfect, but twice as good. And it did this while maintaining 80% overall accuracy and keeping explainability. Every decision could be traced, every flag could be explained using Pygol's logical rules. This was the PhD's contribution to the field. You can't optimise fairness with algorithms alone, but you can engineer equity through architecture. Not through bias mitigation techniques, through routing, through acknowledging the uncertainty that's there, through designing systems that recognise different contexts require different approaches. The ILP approach, inductive logic programming, was critical because it produced rules practitioners could actually understand and challenge. If a student has high absence and in the last 14 days and recent behaviour incidents, then risk is elevated by 3.2 times. Not a black box, not a probability score without explanation, a rule you can interrogate, debate and override, and most importantly, through transparency. Because here's what I realised, the only reason I could fix the bias was because I could see it. I measured it, I published it, I made it impossible to ignore, which raises an uncomfortable question. How many education AI systems out there are actually inspected like this? And that brings me to the second part of this story. Even before I started the PhD journey, discovering that AI fairness was harder than anyone admitted, there was a repeated pattern in the sector. Every few years, the education sector would announce a new initiative to solve interoperability, to get all these different school systems talking to each other. Vector tried it, the Information Standards Board tried it, countless working groups, technical specifications, XML schemas, and every single one failed, not because the technical people weren't smart enough, not because the standards weren't detailed enough. They failed because they were asking the wrong question. The question everyone asks is, how do we standardise the data? It sounds reasonable, doesn't it? Get everyone to agree on the same field names, the same formats, the same APIs, then everything will just work. Except it doesn't. Because here's what actually happens. School A uses SIM, School B uses Arbus, School C uses Bromcom, Trust D has a custom-built safeguarding system that costs £200,000, Local Authority E has a data warehouse from 2012 that nobody quite knows how to update. The NHS uses a completely different patient identifier than schools use for the same child. Police use another system entirely. Social services have their own case management software. And every single one of these systems is already deployed, already paid for, already has years of historical data, already has staff trained on it. Graham Feek, who you'll hear more about in a moment, discovered something during a crisis in Nottingham in 2018. He said, barriers often prevent timely information sharing between partners and within single agencies. Schools utilise different systems to record person safeguarding information, making it difficult to synthesize this information properly. Her Majesty's Chief Inspector in the same year noted agencies, including schools, the police, LAs and community partnerships need to get better at sharing information about gang networks in order to safeguard these children and other pupils. And then this line, which is I want everyone in education technology. Too often, serious case reviews reveal that available information, if considered appropriately, could have prevented harm. The information was there, the systems just couldn't talk to each other. In early 2025, the government conducted research into the value of lost productivity across the public sector due to services being dependent on legacy systems. They estimated this wasted $45 billion a year. To put that in context, that's the value of the entire primary school's national budget. So why does standardisation keep failing? Because how do we standardise the data assumes everyone can agree that everyone will migrate, that we can start from a blank slate, but we can't. With more than 20,000 schools in England, hundreds of different systems, decades of legacy data, commercial vendors with business models built on lock-in, you can't standardise your way out of this. The economic incentives don't align. The migration costs are prohibitive. And by the time you get everyone to agree on version 1, the world has moved on and you need version 2. What instead of asking how do we standardise the data, we asked how do we lower the barriers to using the data you already have? Not standardise, not migrate, not rip and replace, lower the barriers. What if we built systems that could work with SIMS and Arbor and Bromcom and that weird custom system from 2012? What if we treated interop not as a one-time standardisation project, but as a life cycle, a continuous process of reducing friction at every stage? This is what led us to found Open Education AI as a social enterprise, because the life cycle approach requires a fundamentally different business model than commercial companies will achieve. Traditional edtech companies have incentive to create lock-in. The harder it is to leave, the more valuable the customer. But a social enterprise has a different incentive, lower barriers for everyone. OEAI can't extract value and walk away. The life cycle we're building addresses barriers at every stage. Stage 1 is all about data access, building adapters for existing systems. Stage 2 is about data transformation, handling the messy work of normalization, cleaning and enrichment. Stage 3 is about analytics and AI, providing the sophisticated models but with transparency and fairness built in from the start. Stage 4 is about the human decision support, putting insights in the hands of the people who know the children, not replacing expertise but augmenting it. Stage 5 is about evidence and improvement, measure what works, share learnings across the network, lift all boats. And here's the critical part: open by default, not open washing where you release some documentation, actually open code, open models, open evaluations, including the fairness gaps. Because if I've learned anything from my PhD, it's this: you can't fix what you can't see. And the only way to see bias in AI systems is to make inspection the norm, not the exception. Let me get back to Graham Feek's moment of clarity. In 2018, Nottingham Academy, part of Greenwood Academy's trust, was at the centre of a crisis. Gang-related crime, county lines exploitation, weapon-related incidents, multiple students impacted. Graham was part of a team that assembled safeguarding experts, data specialists, police, social services. And after reviewing everything that they knew, everything they'd done, they came to a stark conclusion. We concluded we were doing everything humanly possible. Everything humanly possible. And it wasn't enough. Not because the professionals weren't skilled, not because they weren't caring, but because the sheer volume and complexity of data scattered across different systems, different agencies, different formats, made it impossible for human beings to see the patterns. Graham said something that stuck with me. The subject matter experts demonstrated what I'd describe as algorithmic expertise. They could articulate clear patterns. If this happens, then that follows. They could describe the algorithm. They just couldn't execute it at scale across thousands of data points in real time. That's not a human failure, that's a systems failure. And that's what led to Project Illuminate. We partnered with Graham and Greenwood Academy's Trust to build something different. Not another monitoring system or another dashboard that shows you what already happened, but a system that could synthesize data from multiple sources. The school's MIS, the safeguarding system, attendance records, behaviour logs, even external data like local crime statistics, and identify students who might be at risk before the crisis hits. Greenwood called it Project Illuminate. Here's what we learned. Earlier when I said my PhD model had terrible false positive rates for disadvantaged students, Graham had a completely different perspective on false positives. He said, we're particularly interested in false positives. It's where the model identifies students who may not sufficiently be on our safeguarding radar. So this was interested in the errors, effectively, because in safeguarding, a false positive isn't necessarily a failure. A false positive means the AI thought this student needed help, but when the human looked, they seemed okay. But here's the thing, the human looked. They had a conversation, they checked in, they discovered or knew context that the AI couldn't see. Sometimes that conversation may reveal the AI was actually right. There was something brewing, but just not what the model predicted. Other times the conversation itself might become an intervention. A student feeling isolated suddenly knows someone is paying attention. The model's job isn't to be perfect. Its job is to direct limited human attention to students who might otherwise be invisible. After 4 years of development, the right-hand road, as Graham called it, not the quick path, we're still not sure of how this will scale. Graham's refreshingly honest about the journey. On the timeline, it's taking much longer than expected. Data quality challenges about the significant work needed to improve the quality of data and descriptive analytics, around the complexities in the APIs, and getting those APIs in place was harder because of the preciousness of data, and that's really important. Schools and trusts are rightly protective of student data. Getting systems to talk to each other isn't just a technical challenge, it's a trust challenge. Which is why the ethical framework mattered so much. From the beginning, we worked with the Institute of Ethical AI in Education, not as a rubber stamp, but as a genuine partner in asking hard questions. How do we ensure AI is used beneficially with clear articulation of benefits? How do we prevent significant risks and harms to learners? How do we maintain sufficient transparency so that people can trust the system? We're among the first organisations to complete comprehensive self-assessment frameworks. And we learned something critical, that ethical AI isn't a feature that you add at the end. It's an architecture that you build from the start. That's why Project Illuminate had mandatory human review of every flag. The AI doesn't make decisions, it supports decision makers. It has explainable outputs using data visualization showing spheres of influence, home and family, school, peers and neighbourhood. It has documented uncertainty so practitioners know when a model is confident and when it's guessing. Graham's position was clear. This will function as another piece of management information alongside existing safeguarding data, not replacing human judgment, but augmenting it. While Project Illuminate focused on safeguarding, Inspiration Trust asked a different question. What if we could predict absence before it happens? Not just identify students who've already developed chronic absence patterns, actually predict each morning which students are at risk of being absent tomorrow. So pastoral teams could intervene proactively. A phone call home, a check-in, arranging transport on a rainy Monday. The model analyses 37 distinct features, attendance patterns across multiple time windows, 3, 7, 14, 40 days, calendar intelligence, Monday effects, proximity to holidays, seasonal patterns. Weather data, yes, it turns out rain really does affect attendance. Behavioural segmentation across 25 different clusters, individual student context. And critically, it provides explainability for every prediction, not just this student has a 73% probability of absence tomorrow, but this student has a Monday pattern, has missed 3 of the last 7 days, and similar weather conditions historically correlate with increased absence. Actionable intelligence. The prediction volume chart shows data from the production rollout. The system generates predictions for the full enrolled student population every single day after day, reliably, 11,500 predictions. Here's someone that no one tells you about absence prediction. You're absolutely looking for a needle in a haystack. Absences represent only 5.3% of all sessions, so 94.7% of the time students attend. This is what we call severely imbalanced data. Traditional accuracy metrics become meaningless. You could build a model that just predicts everyone will attend and you'd be 94.7% accurate, but you'd be useless. So we optimize for different metrics, precision recall trade-offs, intervention priority classifications, false positive budgets that pastoral teams could actually manage. The system is deliberately conservative. It underpredicts absence slightly because pastoral teams would rather have 400 manageable predictions than 900 false alarms. It wasn't a technical decision, it was a human-centered design decision. The third piece of this story is the Department for Education AI Content Store pilot. Multi-academy trusts face many different challenges, and in this case we focused on governance. Trustees and governors need to understand complex DfE guidance, compliance requirements, policy frameworks. The volunteers often work in full-time jobs, given 5 to 10 hours a month to governance, and the guidance is vast, scattered across hundreds of documents, thousands of pages, frequently updated, sometimes contradictory. What if AI can help? Not by making governance decisions, but by helping governance professionals find relevant guidance quickly and contextualise it for their specific trust. We built a RAG system that ingests DfE guidance documents, sector body publications, trust-specific policies, provides semantic search across the entire corpus, generates meeting agendas by analysing monitoring visit findings against governance best practice, offers near-term and term-over-term comparison analysis. One governance professional told us, without this contextualisation, boards might overreact to minor concerns or underreact to significant risks. That's the value, not automating judgment, but informing it. The other thing that we learned from the governance pilot that applies everywhere, people don't trust AI that can't show it's working. The system provides citations for every claim, hyperlinks to source documents, flags uncertainty when queries span conflicting guidance. Because in governance, as in safeguarding, as in absence predictions, the AI's job isn't necessarily to even be right. Its job is to be useful, transparent and auditable. Graham said something in 2024 that catches the vision. Development costs absorbed, now translatable to other organisations. This is the social enterprise model working as designed. Each trust that joins makes the system better for everyone else. More data, federated and privacy preserved will mean better models. More use cases mean more shared modules. More trust professionals contributing feedback means better human-centered design. This is the Lifecycle approach at scale. And here's where it gets interesting. Lower barriers to access, we're building adapters for existing systems. Lower barriers to transformation, we handle the messy data work. Lower barriers to analytics, we have sophisticated models transparently evaluated. Lower barriers in decision support, we've got tools and putting tools in practitioners' hands. Lowering barriers to improvement, shared learnings across the network. And we publish our fairness gaps. Because the only way to make AI in education better is to make inspection normal. Now, I know what some of you, perhaps all of you, are thinking. Matt, this is fascinating. Hybrid and simple models, inductive logic programming, confidence-based routing, 11,000 daily predictions, an opportunity to transform education. But I'm trying to get year 8 to understand Oxbow Lakes. I'm trying to help struggling reader in year 3. I'm a governor trying to understand if our safeguarding policy is compliant. Where on earth do I start? The good news is you don't need to understand how the AI works to benefit from what we've learned. And you definitely don't need to build any of this yourself. Let me give you 3 concrete actions. So out of all of these, you can pick one, just one. If you're using any AI system in your school or trust, and you probably are, whether you realise it or not, ask the vendor one question. What are your fairness gaps by socioeconomic status, ethnicity, and SEND? Not, is your system fair? Everyone will say yes. Not, Do you do bias testing? Everyone will say yes. Ask for the numbers, the actual performance breakdown by group. If they can't show you, that's not because the gaps don't exist. It's because they haven't looked, or even they have looked and they're not telling you. And if enough of you ask, vendors will have to start measuring. And once they measure, they'll have to start fixing. And that's how the market will change. The next time you're evaluating a new system, an MIS, a safeguarding platform, or an assessment tool, ask a different question. Not, what does this system do? Ask, how does this system connect to what we already have? Does it have an open API? Can it export data in standard formats? Will it work with the systems we already use? Or are you asking us to rip and replace everything and start again? Because this is something else I know. The best system is severely limited if it's an island. You don't need to become a technical expert on APIs or data standards. You just need to make plays well with others part of your procurement criteria. Every time you choose fair data access over lock-in, you lower the barriers for your school and every other school that comes after you. If you're part of a multi-academy trust or a local authority or even a single school that's interested in evidence-based approaches to attendance, safeguarding or governance, talk to us. Open Education AI exists to lower barriers. That's the entire mission. We work with trusts where they are. Got SIMS, we can work with that. Got Arbor, we can work with that. Got that weird custom system from 2012. We can probably work with that too. The module for CPOMs that we built for Project Illuminate, other trusts are deploying it now. The EES module that brings in weekly national attendance data is available right now in our public GitHub. The network effect means your investment lifts everyone else and everyone else's investment lifts you. You don't need to understand light GBM or Bayesian networks. You need to decide that you're tired of solving the same problems in isolation. Here's what I really want you to take away today. For 20 years, we've been asking, how do we standardize the data? And for 20 years, we've failed because we're trying to solve the wrong problem. The right question is, how do we lower the barriers? Not perfect systems, systems that allow you to access your data. Not unbiased AI even, transparent AI, where we can see and fix the bias. Not replacing teachers and safeguarding professionals, augmenting them. Not proprietary platforms preventing data access, shared infrastructure that's owned by the sector. I started this talk by admitting I'd built a poverty detector. It was hard to say, and it still is. But I said it because I need everyone to understand every AI system in education has bias, every single one. The question is not whether bias exists. The question is, can you see it? Can you measure it? Can you fix it? And the only way to answer those questions is to make inspection normal, to make transparency the expectation, not the exception. So here's my challenge to anyone watching. To teachers, ask about the fairness gaps in the systems that you use. To school leaders, demand access to your data in everything that you procure. To EdTech, publish your evaluation reports, all of them, including the uncomfortable ones. To policymakers, reward openness, incentivize sharing, make transparency a condition of public funding. And to everyone else, stop accepting trust us as an answer, because I've spent at least 7 years learning this the hard way. You can't fix what you can't see. You can't improve what you won't inspect. And you can't build equitable AI in education if you're all trying to save the same problems alone. The advanced analytics and AI lifecycle isn't about the technology. It's about lowering the barriers at every stage so that the technology serves education, not the other way around. We've been trying to solve the wrong problem for 20 years. Let's try and start solving the right one. Thank you.